You can memorize this one. For your test, I will be providing the formula. Don't worry, semua ada. Okay, so hanya perlu faham tahu nak kira macam mana je. Nanti kerja pun you already have the data sheet, you already have the reference, right? Sama lah. Do you need bus for your test?
Yes.
Larilah pergi test.
DK jauh, Bumita DK jauh. Nanti anjing kejar. Anjing kejar.
Anjing kejar tu lagilah bertambah hektik pun.
Tak boleh, ini hospital.
So you need a bus?
Yes.
Okay. This I'm looking. Alright then. Yeah, same theory and operation with the course semua. For the slide, just a 2D punya representation, so might hard to understand lah kan kalau saya explain without any animation. So better tengok video lah. Same goes to this one. The difference of the phase will affect the magnetic field punya rotation. Sama juga yang ni. Okay, now ni dah pun dah already explain previously synchronous speed characteristic. Okay, the synchronous speed of an induction motor ataupun we call it the stator speed because this speed is on the stator. Okay, and then okay, from here the more pole, the faster or slower your motor. The more pole, your motor will be slower. The more frequency, your motor will be higher speed. So put that on your lab report. Okay, this is the finding. Alright, then okay. Previously kita mention pasal slip. Okay, kita ada berapa equation? Kita ada NS 120 F over 4 frequency over 4. Okay, then we have slip tadi. Slip is thank you. N apa? S minus NR over NS. Okay. Ada kalkulator tak? Tak ada. Ada 100. It's in percentage. It's in percentage. Okay. 2 to 8. Dua scale. 0% to 800 ataupun 0.02, 0.08, 1. Two scale. Okay. And then from here, there's another equation which is N slip. Tadi rate of falling, slip to rate of rate pace, kadar kejatuhan ataupun kadar gelinciran, rate of falling. Now, how fast the falling ataupun how fast the slip. Okay, itu adalah N slip. Okay, so it's a different value from synchronous speed and rotor speed. Okay, beza antara halaju rotor dengan halaju stator. Okay, but bila motor in operation, we need to know what is the motor speed. Kita tak tanya synchronous speed, right? Synchronous speed ni we'll be using this term masa bila? Masa nak tahu rated of the motor. Okay, let's say this motor is running at 3000 RPM rated. Itu maximum rated. Tapi on operation kita tak pakai that 3000. Kita nak tahu what is the speed of the motor at a particular load. Let's say your load is 10 ampere. What is the speed? Or your torque load is 10 Newton meter. What is the speed of the motor? Okay, so to find the speed, manipulate all this equation. So motor speed yang mana? This one. This motor speed ataupun load speed. Okay. This one, synchronous speed or stator speed. Okay, nama lain. Percayalah, nama mak bagi lain, nama dekat profile IG lain. Kan? Dia pun nak juga. Okay. So, we need to find motor speed. So, what is motor speed? NR ataupun NM is bawa sebelah. NS minus N slip. Okay. N slip, yes. Satu lagi. Okay, take a look at this. This one sama dengan yang ni, is and flip over and s times 100. Okay, so you boleh rearrange and split S and S. Okay, masukkan sini and S minus S and S. Okay, then factorize the synchronous speed minus S. So this is your motor speed. Okay. Okay, second one, all this N in unit dia, the unit is in RPM. Okay, you may also use omega. This one, omega. So whatever the equation is, you can also write in omega form. Contoh yang ni, omega S minus omega R over omega S. This one, omega split minus omega S tadi 100%. Same goes to this one, omega M, omega S, 1 minus S. Okay. Omega radian per second. Okay. Next. 1 minus S. Okay. Stator have a frequency. Okay. This is your motor and this is your three-phase connection RYB. So you bagi berapa? B415. Frekuensi berapa? 50 Hz, right? So this frequency adalah stator electrical frequency. Okay. So when the stator is energizing the rotor and your rotor started to move, rotor it has its own speed and also its own frequency. Okay. So this is the so the rotor frequency is split multiply with frequency stator. You can also rearrange the equation mana ni, NS and split. Oh, okay. Kita start dari sini. So actually they're expanding the equation here. So FR E S F S E. So S adalah NS tolak NM ini. Okay. NS minus NR. Purposely I'm writing the different term sebab nak you tahu NN and NR is the same thing. Okay. NS ini adalah S. Okay. And SE. Okay. And you remember yang frequency stator ni juga. This frequency stator ni adalah NS 120 F over pole. So this F adalah frequency stator. So kita replace dia jadi this equation will be FSE NS V over 120 kan. Now isi bawah V over 120 NS minus NR over NS. Cancel out lower part and upper part, and you have V over 120 NS minus NR. Oh, tertinggal. V 180 NS tolak N. Something missing. NS. Oh, N. Betul. Okay. Kita setting sebenarnya. Okay. Yang ni not that important, but you need to know kalau if you wanted to proceed your elective with electrical machine design. Okay, the relationship between rotor magnetic field relate with the rotor frequency and speed of the motor. Okay, so when you increase the speed, okay, magnetization ni ada satu issue. There's one issue for magnetization, which is saturation. At one point, no matter how much you give, it won't go further anymore. Tapi dia akan reduce. Itu dah panggil saturated. Magnet memang macam tu. Okay. So as it go higher, the magnetic field of rotor will become decrease. But the total magnetic field will be same. Sebab dia tengok dekat sini. Okay. Ini adalah cross section of the rotor. Okay. Kalau nak belajar further, dia ada vector of rotor magnetic field, and this one is vector of stator magnetic field, and this is the V net. So V net ni akan always flat walaupun you increase speed. Okay, sebab ini supply stator kan sama je, tak berubah kan. Sebab tu dia flat. Okay, power factor, ya, motor pun ada power factor sebab dia involve dengan sinusoidal waveform. So the more speed, the value will be closer to the 1. Closer to 1 maksudnya bagus ke tak? Is it good or not good? It's good because the efficiency is almost 100%. Okay, so this one yang saya draw dekat sini tadi, you already learn. So pull out torque is maximum torque. Full load torque adalah operation torque. Starting torque is starting torque lah. This one, okay. Cuma dia letak the speed is on the x axis and the torque is on the y axis. Okay. So this is your synchronous speed. So when you bring your car turun bukit, slowing down pula, dia akan jadi faster. The rotor will be faster and it will become a generator. Tapi when actually practically, bila jadi generator ni, what happen to the energy? Exit energy ni akan pergi ke mana? Bila jadi generator, dia akan generate energy, right? Yeah. So where does this energy go? Kalau tidak kan kita bagi energy, kita bagi dia supply. Pergi ke? Yes, betul. Go back to the battery. Kan dalam kita ada battery. Okay, let's try this one.
Nak ke berapa?
Naik ke berapa Allah Alam dia tak tahu.
Dia pilih.
Flat 50. 50.
50. Kau set berapa?
50.
50.
50.
49. Buku
Apa maksud? Apa maksud?
ni tak faham lagi. Cantik dia tulisan kan. Kat bawah tu kan dia dah ada solution.
Nak pergi duduk toilet?
Boleh, kita boleh. Kita pergi dulu.
Actually jawapan ada je. Dalam slide ada kan?
Ada. Kita je nak buat.
Kalau buat
Behind the
kalau pilih lagi sama.
Okay, what you need to know is when you give horsepower, this is P in or P out? Pandai, P out. Okay. Then pole. Sometimes kalau you rajin baca buku teks, you are frequent reader of textbook. This one will be pole pair. Okay. Let's say with pole pair of 2, so you need to convert it to number of pole. Pole it will be 4. Kan pole kan sepasang-pasang kan. So kalau 2 pasang maksudnya bilangan pole tu ada 4 lah. Number of pole will be 4. Alright. This frequency is F frequency stator. S is stator electric. Okay. Okay ni dah tahu 120 F per 60. Kita tengok. Motor speed. Okay, so this is how we find the motor speed by using this equation most of the time. Okay. Slip. When it say 5%, so it's 5 over 100, so it will be 0.05. Frequent mistake, you akan letak 5 di sini. 0.5 di sini. So, salah. Salah ke atas, yang bawah semua dapat separuh. That's how you lose your mark. Okay? So, it's 0.05. Then, you will have your motor speed. So, now, you can verify that rotor speed will be always lower than stator speed ataupun synchronous speed. So, betul lah. Okay. Next, the rotor frequency. So kita ambil slip yang ni, nilai yang sama, the same value, and this one is stator frequency given by the question. Okay, and it's 3 Hz. You can double check your answer with this equation. F S M FRE. Okay, and double check the answer. It will give you same 3 Hz. Okay. Yang ni penting. Load torque. Okay. Dalam motor, dia ada 2 torque actually. Load torque, lagi satu induced torque. There's 2 type of load. Load torque and induced torque. If you remember the structure of the stator, okay. At this, dekat rotor, at rotor, you can measure the load torque. Okay. Tapi at stator, in between stator and rotor, they have one torque which is induced torque. TIMP. What's the difference? Load torque, that one. P out over motor speed. Sebab dia dekat rotor. But induced torque is P air gap over synchronous speed. Okay, stator speed. Okay, so question is asking for load torque, so output power over motor speed. Output power is horsepower. Careful, you need to convert it into electrical term. Mechanical term ni horsepower ni. Convert dalam electrical term. Siapa tak tahu convert pakai calculator? Ada function convert, right? Ada tak? Dalam exam tak boleh bawa handphone, tapi calculator boleh bawa. Pakailah function convert. Ada yang tanya, Doctor, what is the conversion rate of horsepower? Is 746 or 7447? Macam tu dia tanya saya. Convert automatically using calculator. Okay? Okay, convert. So you can eliminate the horsepower. So now tinggal watt. Dan your motor speed. Okay? Omega in radian per second, so you need to convert ke dalam radian per second. Okay? RPM ni sebenarnya 1710 RPM, round per minute. Okay? To convert to radian per second, you need to multiply with 2 pi over 60. But to reduce common mistake, saya suka buat pi over 30 je. Sebab takut tersilap tekan calculator. 10 multiply 10 multiply to 746 divide by 1710 multiply balik, so akan ada banyak apa? Error. Kan? So multiply with pi over 30 and you will have 41.7 Newton meter. Itu shaft torque ataupun load torque. Ada je jawapan kat belakang ni. Boleh refer. There are 2 techniques which can speed of induction can be controlled. One is to vary the synchronous speed. Mana synchronous? Okay, vary the synchronous speed. Since the rotor speed will always remain near the synchronous speed. So how to vary your synchronous speed is by varying the frequency. Okay. Okay. Another one to control the slip, the speed of the rotor is by varying the slip. Okay. If your slip is 5%, you will have this one. So kalau dia 8%, you akan dapat different motor speed. And you nak control slip ni macam mana pula? Okay. Slip control may be accomplished by varying either rotor resistance or terminal voltage. Okay, rotor resistance dalam rotor winding tu, or the supply the supply voltage that given to the stator. The only way which the synchronous speed and the synchronous speed of the machine can be varied is by changing the electrical frequency. Yang ni lah. changing the electrical frequency by variable frequency control. Actually, it is actually a drive. Antara supply dengan motor tu ada drive. So dekat situ baru boleh dikontrol. Change the number of pole ni by construction. So kalau you the one that construct your machine, then you can control ataupun you can change this number of pole. Okay, tapi usually when you buy a motor, it's already fixed. The pole is already fixed. Okay, power flow diagram kita continue next class. Okay, thank you very much for your time. Assalamualaikum warahmatullahi wabarakatuh.